Good day, grade 8 learners, and welcome to 2023. I hope you had an enjoyable and restful holidays. Welcome to our mathematics lesson. My name is Mshumali Nyati, and this lesson is proudly brought to you by the Gauteng Department of Education. Today, we are going to be looking at whole numbers, where we'll be dealing with HCF and LCM. We expect that by the end of this lesson, you should be able to find prime numbers. We also expect you to be able to find the highest common factor, which in short we may refer to as HCF, as well as finding the lowest common multiple, and in short we refer to as LCM. In our previous grades, as well as our previous lessons, we learned about factors as well as multiples. So before we start our lesson, I would like us to do the following baseline activity, which will help us remember some of the things that we learned and also prepare us for the lesson ahead. So I'm going to give you some time to express 18 as a product of its prime factors. Right, I'm going to give you that. Thank you. Two minutes, then we continue. Thank you.
Believe in yourself. Believe a little more in yourself, because to those that believe, nothing is impossible. You have done this before. You have passed your tests before. You have went into a higher grade before. It is possible because you have done it before. Do not doubt yourself. Keep believing in yourself. Keep pushing, because this can be done and you can be great. You have been given power to decide whether you want good results in your life, in your schoolwork, or you want bad results. As Tony Robbins said, it is in the moment of your decision that your destiny is shaped. And your destiny is shaped right now with the decisions that you are currently making in your schoolwork. So decide whether you want to be an A student and start working on it, because there is power inside of you. The infinite power is inside of you, and the time you decide to tap in that power, you will become who you want to become in your schoolwork. To decide whether you want good results in your life, in your schoolwork, or you want bad results. As Tony Robbins said, it is in the moment of your decision that your destiny is shaped. And your destiny is shaped right now with the decisions that you are currently making in your schoolwork. So decide whether you want to be an A student and start working on it, because there is power inside of you. The infinite power is inside of you, and the time you decide to tap in that power, you will become who you want to become in your schoolwork.
Where does it put the formatting or not?
Welcome back, grade 8 learners. Now let's go through our baseline activity together, where we've been asked to express 18 as a product of its prime factors. We have got two methods that we can use. The first one is the division ladder method. Right, so if we've got our 18 there, right, we divide it by the lowest prime factor, which is 2. If you divide 18 by 2, what do you get? You get 9. Right. Then from there, can you divide 9 by 2? No, we move on to the next prime factor, which is 3. If you divide 9 by 3, what do you get? It's 3. 3 is the prime factor on its own, so we can only divide it by 3 or 1. So if you divide 3 by 3, you get 1. Therefore, 18 as a product of its prime factors is equal to 2 times 3 times 3. We also have another method, which is the vector tree method. Right, in that one, we use the same prime factors. If you divide 18 by 2, you get 9. Right, you get 9 there. You know that if you want to check, then 2 multiplied by 9 gives us what? 18. Right, for us to express 9 as a product of its prime factors, what do? We divide by 3. 3 into 3, 3 into 9, sorry, is 3. Because 3 times 3 gives us 9. Then we are left with the 3 there, so we divide it by 3. Then we have 3 multiplied by 1. Right, you might find that others prefer they do it this way. Right, they end there. So it depends with what your teacher has already taught you. So we have these two methods. So it's up to you to use the one that you are comfortable with, or the one which your teacher has already taught you. So 18 as a product of its prime factors is equal to 2 times 3 times 3. Right, for those who need to write corrections, let's quickly do so before we move on to another question. Let's quickly write our corrections there. Right, I'm going to give you some time there, about a minute or two. Welcome back, grade 8 learners. I hope you have managed to write your corrections for those who needed to do so. Now let's continue with our lesson and have a look at some of the important terms that will help us understand our lesson. The first one are factors. Factors of a number are all the numbers that divide exactly into a number without a remainder. For example, the factors of 16 are 1, 2, 4, 8, and 16 itself. We also do have prime factors. Prime factors are the factors that are prime numbers. That is, numbers that have got only two factors, 1 and the number itself. So that is the definition of prime numbers. It is a number with two factors, which is 1 and the number itself. Examples of prime numbers are 2, 3, 5, 7, and so on. So these are the numbers that have got only two factors, which is 1 and the number itself. As you saw there when we were doing our baseline activities, right, we decompose or reduce that number into the product of its prime factors. Still on our terminology, let's have a look at multiples. Multiples of a number are all the numbers that divide, are all the numbers which the number can divide into without leaving a remainder. For example, the first 4 multiples of 3 are 3, 6, 9, 12. As 3 divides into 3, 6, 9, and 12 without leaving a remainder. Then we do have composite numbers. Right, these are numbers with more than 2 factors. In other words, they are all natural numbers greater than 1, which is not prime. For example, these numbers 4, 6, 8, 9, and 10. If you check 4, which factors do we have for 4 there? If you say 4 times 1, right? So 1 is a factor, 2 times 2. So 2 is a factor, right? As you can see there. So 4 has got how many factors? It has got 1, 2, and 4 itself. So it has got more than 2 factors. Therefore, we call these numbers composite numbers. And remember, the numbers that have got only 2 factors, which is 1 and itself, they are called what? They are called prime numbers. Remember to interact with us on our WhatsApp number, which is 079 454 9535. If there is anything that you do not understand, please contact us via WhatsApp. On that number, we do have a team of dedicated teachers this side, which will answer you right. Now, I'd like us to have a look at the highest common factor. Right, the highest common factor, which in short we write as HCF. The highest common factor that is common to 2 or more numbers. For example, we want to find the highest common factor of 12 and 16. What can we do? We can first list the factors of 12. If we list the factors of 12, we do have 1, 2, 3, 4, 6, and 12 itself. And then if we list the factors of 16, we do have 1, 2, 4, 8, and 16 itself. Right, so here we are looking for the factor that is the highest and common to both numbers. If you check there, 1 is the factor of all the numbers, so we won't consider that. 2 is common to both numbers. But is it the highest? No, it's not. So let's move on. If we move on, which one is common? Once again, is 4. 4 is common to both numbers and it is the highest. Therefore, we can say that by inspection, because we simply inspected there, by inspection, we can say the highest common factor of 12 and 16 is equal to 4. But let's consider that you are given very big numbers. For example, if you are given 36 and possibly 72. If you are to identify the highest common factor of these numbers by listing them, it will be a lot of work. It will be really a lot of work. So there should be an easier and shorter way that we can use to find our highest common factor. Right. So now we can use a shorter method of prime factors. We can use a shorter method of prime factors to find the highest common factor. For example, the following numbers are expressed as the product of their prime factor of their prime numbers. Right. 12. If you have to express 12 there, it is 2 times 2 times 2. 2 times 2 times 3. Because if I'm going to use the division ladder method, it's going to be 2 into 12 is 6, and 2 into 6 is 3. 3 into 3 is 1, which gives me 2 times 2 times 3. Then for 16, right? Let's just clear there, right? I might also need to write these factors using exponents. 2 times 2, I can write that exponentially as 2 to the power of 1, and 3, I can write that as 3 to the power of 1. If I'm to express 16 as a product of its prime factors, what do you get? I have 2, it's going to give me 2 times 2 times 2 times 2. This is what we got. This is how we got it. 2 into 16 is 8. 2 into 8 is 4. 2 into 4 is 2. 2 into 2 is 1. Therefore, that's how we got this 2 times 2 times 2. And we can write the factors exponentially there as 2 to the power of 4. Right. It is very important for us to know how to write these factors exponentially, because it will help us as we progress. You will see how it will make our work easy as we progress with the lesson. Now, I would like us to do the following example together. We have been asked to express 24 and 36 as a product of its prime factors. Right, we are going to do that together, right? So 24 there, we'll divide 24 by the lowest prime factor, which is 2. 2 into 24, what do we get? We get 12, right? Can 12 still be divided by 2? Yes. 2 into 12, what do we get? 6. Can you still divide 6 by 2? Yes. 2 into 6 is 3. 3 is the prime factor on its own, so we're going to divide it by 3. Therefore, our 21 as a product of its 24, sorry, as a product of its prime factors is going to be 2 times 2 times 2 times 3. Then we do have 36. 36 as a product of its prime factors. We divide 36 by what? Let's try that. On our own there, let's do it. I'm going to give you some time to try that on your own. Let's express 36 as a product of its prime factors. I'm going to give you 2 minutes to do that. Let's do that. Right, for the sake of time, I was also doing it whilst you were busy there. So 36 is the product of its prime factors. If you divide 36 by 2, you get 18. You divide 18 by 2, you get 9. Which prime number can divide 9? Can get into 9 is 3. 3 into 9 is 3, then 3 into 3 is 1. So 24 and 36 as a product of its prime factors is equal to For the 24 is that one, and for 36 is that one. Right. Now let's move on to the second part of our question, where we've been asked to determine the highest common factor of 24 and 36. This time we are going to be using these prime factors. So I want you to pay attention on how we use these prime factors to find the highest common factors of numbers. Right. The highest common factor will always be the product of the bases which are common to both numbers with the lowest exponent. Right? So I want you to take note of that statement. The highest common factor will always be the product of the bases, right? The bases in this case, these are our factors, which are common to both numbers with the lowest exponent. But before we look at this, let's list again our product, our numbers there as product of their prime factors. Right, if you are to check there, which ones are common, which numbers are common. But before we do that, let's write these bases or factors as exponents. We do have 2 times 2 times 2 is 2 to the power of 3 times 3 to the power of 1. And then 36 there is 2 times 2 times 3 times 3. We write it as 2 to the power of 2 and times 3 to the power of 2. Right. Using this first method, if you check there, the factors which are common there is 2 and 2. Right. This is the first method. The factors there which are common is 2 and 2, as well as 3 times 3. Right. So I can rewrite those factors by multiplying them, which will give me 2 times 2 times 3, which will give me 12. Otherwise, I will have to be guided by this statement, which says the highest common factor will be the product of the bases which are common to both numbers with the lowest exponent. So if you look at the bases, the 2 is common, but I'm taking the lowest base, which is 2 to the power of 2. And then the 3 and 3 to the power of 1 and 3 to the power of 2 are common, but I'm taking the lowest base, which is 3 to the power of 1. And then if I multiply those, I'm going to get 4 times 3, and that will give me 12, which is exactly the same answer. Right. So let's go through this together once again. Let's go through this together once again. Can you see how we did it? The first one there, we looked at the factors that are common. We circled them. The 2 there, right? The 2 and 2 are common. Then I wrote it there. The 2 and 2 are common. I wrote it there. The 3 and 3 are common. I wrote it there. Then I found the product of these common factors, and then I got the 12. That is the first method. Then the second method, I looked for the bases which are common to these numbers with the lowest exponent, right? So 2 is 2 to the power of 3 times 3 to the power of 1. 36 is 2 to the power of 2 times 3 to the power of 2. So the bases which are common is 2, which are common and is the lowest, is 2 to the power of 2 times 3 to the power of 1. If you simplify that, we get 4 times 3, which will still give us 12. So these are 2 different methods. It's up to you to use the method that you are comfortable with. Right. It is up to you to use the method that you are comfortable with. Now let's move on and do another example. We've been asked to find the highest common factor of 60, 84, and 90. Right. So what I want us to do is to first express these numbers as product of their prime factors. Right. So if you're expressing 60 as the product of their prime factors, we are going to get 2 times 2 times 3 times 5. And 84, we are going to get 2 times 2 times 3 times 7. And then 90, we are going to get 2 times 3 times 3 times 5. Right. I'm also going to rewrite these factors as in exponential form, which will give me for 60, 2 to the power of 2 times 3 to the power of 1 times 5 to the power of 1. For 84, it's 2 to the power of 2 times 3 to the power of 1 times 7 to the power of 1. And for 90 is 2 to the power of 1 times 3 to the power of 2 times 5 to the power of 1. Now, using the first method, the 2 there is common, right? What else is common there? We have the 3, right? There, the 2, this side we don't have the 2, we have the 3, which is common. Is the 5 common? No, we don't have it where there is in 84. So, for us to find the highest common factor, using the first method, we multiply the 2 times the 3, which will give us 6. Right, now using this method, we look for the product of the bases which are common to both sides with the lowest exponent. Which one is the lowest exponent? For 2, it is 2 to the power of 1, which is this one. And the lowest exponent for 3 is 3 to the power of 1, which is that one. Then if you simplify, you are going to get 2 times 3. Then that will give us the same answer as this side, which is 6. Right. Now, I'm going to give you a class activity where we are going to find the highest common factors of these sets of numbers, which is 21 and 84. That is for A. And then for B, it's going to have 120, 300, and 900. So I'm going to give you some time to do A. Let's first do A. I'm going to give you 4 minutes to do that. When we come back, we'll go through it together. Thank you. Welcome back, grade 8 learners. Remember to interact with us on our WhatsApp number, which is 079 454 9535. I hope you are done there. Please take this time to copy question B, right? Because after we are done with question A, I'm going to give you some time to write your corrections, and then we move on to question B. So just copy it down so that after that, you still have it, where you need to find the highest common factor of 120, 300, and 900. Now let's move on to question A. Right. Remember, there are two methods that you are going to be using. The other method requires us to find the product of the bases which are common to both numbers with the lowest exponent. Right. So 21 there, if you are to express 21 as the product of its prime factors, is equal to 3 times 7. 84 as the product of its prime factors is 2 times 2 times 3 times 7. Right. We can write this in exponential form. 21 is 3 to the power of 1 times 7 to the power of 1. And 84 is 2 to the power of 2 times 3 to the power of 1 times 7 to the power of 1. So this is the first part that you're supposed to get, right? Because if you got your prime factors wrong, you won't get the correct answer. So just make sure that you've got the correct prime factors. So you can quickly write your corrections there for the correct prime factors if you made a mistake. Now, looking at the first method, which factors are common? We do have 3 and 7. If you multiply 3 times 7, you get your 21, right? And then, if you are to use the second method, where we need to find the product of the bases which are common, but with the lowest exponent, 3 to the power of 1 is the common one with the lowest exponent, and 7 to the power of 1 is common with the lowest exponent. If you multiply that, you still get the same answer, which is 21. So let's quickly write our corrections there, and then we move on to part B. Let's quickly write our corrections. I'm going to give you 2 minutes to do that. Thank you.
Believe in yourself. Believe a little more in yourself, because to those that believe, nothing is impossible. You have done this before. You have passed your tests before. You have went into a higher grade before. It is possible because you have done it before. Do not doubt yourself. Keep believing in yourself. Keep pushing, because this can be done. And Believe in yourself. Believe a little more in yourself. Because to those that believe, nothing is impossible. You have done this before. You have passed your tests before. You have went into a higher grade before. It is possible because you have done it before. Do not doubt yourself. Keep believing in yourself. Keep pushing because this can be done and you can be great.
Ufake lokhu amahadi. Now let's do part B. I'm going to give you 4 minutes once again to do part B. Remember, you first need to express these numbers as product of their prime factors, and then from there, you apply any of the two methods which I've shown you to calculate your highest common factor. Let's do that, 4 minutes.
Do you know that you are different? Do you know that your fingerprint is different? Is different from your peers, from the people that you are studying with. So do not compare yourself with your peers. Do not compare your results with what they're getting, because you are different. You have your own talents and skills, and also you have your own gifts. Embrace what you can do. Always put in the work to make sure that your results become better than what they were yesterday. But do not compare yourself, because when you compare yourself, you do not know what another person has, and they do not have what you have. So believe in yourself. You are different, and keep on putting the work.
Hey learners, remember to interact with us on our WhatsApp number, which is 079 454 9535. Now, let's do our part B of the question. Like I said earlier, we first need to express these numbers as product of their prime factors, right? So if you have to express 120 as a product of its prime factors, it is equal to 2 times 2 times 2 times 3 times 5. And then 300 is equal to 2 times 2 times 3 times 5 times 7. Times 5, sorry. And then 900 is equal to 2 times 2 times 3 times 3 times 5 times 5. Now, let's first express these factors as exponents. 120 will give us what? 2 to the power of 3 times 3 to the power of 1 times 5 to the power of 1. 300 will give us what? 2 to the power of 2 times 3 to the power of 1 times 5 to the power of 2. And then lastly, 900 will give us what? Is expressing the vectors as exponents. We are going to get 2 to the power of 2 times 3 to the power of 2 times 5 to the power of 2. Right, using the first method, let's look at the factors that are common to all the three numbers. We do have a 2 there, right? And also have a 2 there, right? And also have a 3 there. And a 5, right? Which will give us 2 times 2 times 3 times 5. That is the first method. With the second method, we look at the common basis with the lowest exponent, which is 2. For 2, it is 2 times 2 to the power of 2. For 3, it's 3 to the power of 1. And then for 5, it's 5 to the power of 1. And then that will give us the same answer, which is 60. So for those who need to write corrections, let's quickly do so. I'm going to give you 2 minutes to do that. Thank you.
Believe in yourself. Believe a little more in yourself, because to those that believe, nothing is impossible. You have done this before. You have passed your tests before. You have went into a higher grade before. It is possible because you have done it before. Do not doubt yourself. Keep believing in yourself. Keep pushing, because this can be done and you can be great.
Right, welcome back, grade 8 learners. I hope you managed to copy your corrections. Now, I'd like us to move on to the second part of our lesson, where we're going to be looking at the lowest common multiple. I want you to pay attention because some of you confuse the way how you calculate your highest common factor and the lowest common multiple. Right, let's first define what a lowest common multiple is. The lowest common multiple, which we refer to in short as LCM, it is the lowest multiple that is common to two or more numbers. We can find the LCM of two or more numbers by listing as many multiples as you need until you find the one that is common to both or all numbers. Right. For example, if you are to find the lowest common multiple of 9 and 12, listing the multiples of 9, 9, 18, 27, 36, 45, 54, 63, and 72, right? There are many, but for now, I'm just ending there. And then the multiples of 12 are 12, 24, 36, 48, 60, 72, and 84. Now, what are we looking for? We are looking for the lowest common multiple, right? So what do we do? By inspection, the first time the multiples match up is at what? The first time the multiples match up is at what? You do have a 9 and 12 there. You do have 18 and 24 there. You do have 27, it's not there. You do have 36 there. So the first time the multiples match up is at 36. Right, just like the highest common factors there, if you are to list factors, we say that it can be a lot of work. The same here, if you are to list the multiples of numbers, it's also going to be a lot of work, especially if it is big numbers. So there should be an easier way that we need to use, right? That method will also need us to apply our knowledge of prime factors. So therefore here, by inspection, we can tell that the LCM of 9 and 12 is equal to 36. Right. Instead of writing out a long list of multiples for each number, we can use the prime factor method to find the LCM, or the lowest common multiple. Right, we do have 9. If you are to express 9 as a product of its prime factors, it is equal to 3 times 3, which we can write in exponential form as 3 squared. And then if you are to write 12 as a product of its prime factors, it is equal to 2 times 2 times 3, which we can write in exponential form as 2 squared times 3 to the power of 1. Right. Now, I want us to use our knowledge of prime factors to find the lowest common multiple. But we need to know the following, right? Like I said, let's not confuse how we find the lowest common multiple with the way we use to find the highest common factor. With the lowest common multiple, the product of each base with the highest factor. We need to find the product of each base with the highest exponent. Right? Can you see that? With the highest common factor, we're looking for the product of each base which is common to both numbers, but with the lowest exponent. But with the lowest common multiple, we are looking for the one with the highest exponent. For example, there, our 3, we had written it earlier as 3. Our 9, we had written it earlier as 3 times 3. In exponential form, it is equal to 3 squared. And our 12 is equal to 2 times 2 times 3, which is equal to 2 to the power of 3. Right, so with LCM, we take the base which appears the most, right? So 3 there appears how many times? 2 times. Okay, I may start with 2. 2 appears 2 times, so we write there 2 times 2. And 3 appears where? 2 times, we write it there as 3 times 3. To simplify that, we are going to get 4 times 9. Right, using the other method, just like the HCF, we have got 2 methods to use. In this case, we need to find the product of the bases with the highest exponent. So the highest exponent for 2 is 2 to the power of 2. And the highest exponent for 3 is 3 to the power of 2. So which will give us 2 to the power of 2 times 3 to the power of 2. If you are to simplify that, you're going to get 4 times 9, and that will give us an answer which is equal to 36. Right, which is exactly the same answer as that one. As you can see, just like the HCF, we've got two methods of finding the LCM. Right, there's this one where we need to pick, the where we need to first pick the factors, and this one where we use the exponents. Now let's do another example where we're going to find the LCM, but this time of three numbers. So we need to determine the LCM of 6, 8, and 15. So what we need to do first is to express these numbers as product of their prime factors. So let's do that. Let's do that together. I'm going to give you some time. Whilst you're doing that, I'll also be doing it. Yeah. So I'll give you 2 minutes to express 6 as a product of its prime factors, 8 as a product of its prime factors, then 15 as a product of its prime factors. Then from there, we proceed to find the LCM. Thank you. Welcome back, grade 8 learners. Remember to interact with us on our WhatsApp number, which is 079-454-9535. Now, if you are to express 6, 8, and 15 as a product of their prime factors, 6 is equal to 2 times 3, 8 is equal to 2 times 2 times 2, and 15 is equal to 3 times 5. And we can express these factors as bases in exponential form. For 6 is 2 to the power of 1 times 3 to the power of 1. 8 is equal to 2 to the power of 3. And 15 is equal to 3 to the power of 1 times 5 to the power of 1. Now, using the first method to find the lowest common multiple, right? We look at the factors there, right? We look at 2, where does it appear the most? In this case, it doesn't have to be common, right? It doesn't have to be common. We take any factor, right? As long as we take it where it appears the most. So with 2, with 8, it appears how many times? 3 times. And then with 3, it only appears once. So we only take it there once. and 5, it only appears once, so it only take it there. So using this first method, our lowest common multiple will be equal to 2 times 2 times 2 times 3 times 5. Then if you simplify that, you are going to get 8 times 3 times 5, which at the end will give us 120. Right. Using the second method, right, you are going to find the product of the base with the highest exponent. So if you're having a look there at 2, where does it have the highest exponent? Where there is 8 there is 2 to the power of 3. And then the 3 there, it is 3 to the power of 1. That is the highest exponent. For 5, it is 5 to the power of 1. So the product will give us 2 to the power of 3 times 3 to the power of 1 times 5 to the power of 1. Then if you simplify that, you are going to get 8 times 3 times 5, which still gives us the same answer, which is 120 there. Right. So for those who need to write corrections, or need to write these as notes, I'm going to give you a minute to do that before we continue. Thank you. Welcome back, grade 8 learners. Remember to interact with us on our WhatsApp number, which is 079-454-9535. Now, I would like us to copy the following class activity, right? You will do it as your homework because of time. You no longer have time left. So I want you to copy the following class activity where you're supposed to find the LCM for these sets of numbers, which is A, 24 and 90, and then B, 90, 105, and 150. What you need to note there is to first find the prime numbers of these, the prime factors of these numbers, and then from there we apply the knowledge that we learned in our examples to find the LCM. So I'm going to give you a minute to quickly copy that before we continue with our lesson. Thank you. Welcome back, grade 8 learner. Now it's time for our homework. Remember, as I always emphasize, that in mathematics, we need to practice. The more we practice, the better we become. And we're also going to enjoy the subject. So now it's time for our homework. Please copy the homework and do it. Your teacher is going to check if you manage to get your questions correct. So let's quickly copy the following homework and then we summarize our lesson. Thank you. I'm going to give you 2 minutes to do that. Thank you. Welcome back, grade 8 learners. Now, we didn't receive any WhatsApp questions there, right? I hope that means you understood whatever we're learning, right? Now, let's summarize our lesson. What is it that we learned about? We learned about prime factors, which are factors that are prime numbers. That is numbers that have got only two factors, which is 1 and the number itself. We also looked at the highest common factor, which is HCF, where we used our knowledge of finding prime factors to find the highest common factor of two or more numbers. We also looked at the lowest common multiple, which is the LCM, where we also used our knowledge of finding prime factors to find the lowest common multiple of two or more numbers. I really hope you enjoyed this lesson. Until we meet again next week, where we are going to be solving problems involving whole numbers, including ratio and rate. Until then, please remember to stay safe and study hard. Goodbye and thank you.